Hello everyone, today we'll look at periodic trend. This lesson is taken from IAL Chemistry for 2024. Let's start with something you're familiar with. We're looking here at a model of the sodium atom. So you can see there's a nucleus in the center and there are the electron shells around this. But this model is far from being accurate. The reality is that electrons are always in motion and it's really difficult to determine the exact position of an electron around the nucleus. So what we see here is that the electrons form a cloud around the nucleus with blurry edges. Now, this distance from the center, which is the nucleus, all the way to the edge, which is the valence electron, is what we call an atomic radius. The question here is, how did scientists figure out the atomic radius? The atoms are really tiny and that edge of the atom is quite blurry. So how did they figure out that distance from the nucleus to the valence electron or the atomic radius? What scientists did is really smart. They took two adjacent atoms and they measured the distance between the nucleus of the first atom on the right and the nucleus of the atom on the left. And this distance is equivalent to 2 times the atomic radius. So simply, if you could just divide this distance by 2, you will figure out the atomic radius of each one of those two atoms. Now, they did this for the entire atom of the periodic table, and they figured out the periodic trends of the atomic radius. The atomic radius changes in a very predictable way in the periodic table. So if you go from top to bottom in any group of the periodic table, you'll find that the atoms are getting bigger. The atomic radius is increasing. If you go from left to right across a period, you will find that the atomic radius is actually decreasing. Now let's take an example. Let's take the first group of the periodic table. If you go all the way from lithium, sodium, and potassium, you'll find that the number of shells or energy levels is actually increasing. And it's quite obvious, the greater the number of energy levels, the larger the atomic radius is. Now we still have one more thing to explain here. Why is it if you go from left to right across a period in the periodic table, the atomic radius decreases? So if you go from sodium all the way to argon in the third period of the periodic table, you'll find that the atomic radius is actually decreasing. Now this has something to do with the nucleus. The protons in the nucleus have an attractive force towards those electrons in the shells. So the greater number of protons, so for instance, sodium has 11 protons, magnesium has 12, all the way we go to argon, you have 18 protons. Now, obviously, 18 protons in the center will attract electrons in a stronger way than the 11s of sodium. I always think of the nucleus as a magnet. Now, the nucleus of sodium is quite weaker than the nucleus of argon because that magnet or nucleus of sodium has only 11 protons. Now, those 11 protons have weaker attractive force than the 18 protons that you have with argon.